All right, moving on to the another order up of animals. Now we're getting to the point with animals where we're not getting more and more advanced. Now we're starting to just see radiation, radial adaptation. Mollusks are highly advanced organisms. I know we don't think of them as such. You don't look at a snail and you're like, that's pretty freaking highly advanced right there. But they are. The mollusk body plan has basically three components: a muscular foot, a visceral mass, and a mantle. So that foot is used for movement, and it's been adapted. So obviously in a snail, you've got a single structure. That single structure in an octopus has been subdivided into 8 pieces. Think of these 8 pieces as almost the edges of that foot, that each are able to independently move and interact with the environment. In a squid, it's broken into 10 pieces, and so on. So you've got a foot, then you've got a visceral mass that sits right on top of the foot. The visceral mass has all of the organs in it. It's also got a very complex heart and a brain. So you've got a heart that's pumping a type of blood fluid through the organism to move oxygen. Now, it doesn't really have lungs like we have. Instead, a mollusk has what's known as a mantle. That's where gas exchange occurs. So basically, in this mantle, you've got fluids running, being pumped by the heart, running up close to the surface, getting oxygen through diffusion, and then moving back through the rest of the organism. It's not an active respiration like you and I have, where we take in a deep breath and then we let it out. It's just sort of a passive diffusion of the oxygen over it. I think mollusks are going to be the next big step in evolution. Once we wipe ourselves out, mollusks are what are coming next. And there's a few different reasons for that. One, they're smart. They're super smart. Octopods are, they can remember and reapply knowledge. They can use tools. You actually, we've had mollusks that will take sticks in order to scoop out shrimp from containers. They problem solve. They're escape artists. They've got a massive brain that's useful for problem solving. Say that again? They're what? Playful. They are playful. And play is actually a huge sign of intelligence. So there we go. I think they're up next. The cephalopods, they're going to move by jet propulsion. They shoot water behind them. So instead of, they could crawl, and you probably see them doing that, using their tentacles pulling along the ground. They can come out of the ocean, walk around on land for a bit for funsies. They also, behind them as they're moving free swimming through water, can push water behind them in order to have this jet propulsion effect. They have a closed circulatory system just like you do. That is, they've got a heart that pumps fluid through the body that transports oxygen. They also have extremely complex eyes. Their eyes are functionally identical to yours, but they came about in a completely different way. This is an example of convergent evolution, but their eyes can see exactly what your eye sees. A lot of cephalopods have chromatophores on their skin. This allows them to change colors and perfectly blend into their environment. And oftentimes they're doing this not by instinct like we used to think. They're looking at their environment and consciously changing the way their skin looks. They can use this for communication. They can use this for trying to scare away a predator. They can use this to hide. They also have extreme control of their muscles that we lack. They can change the structures on the texture of their skin. Our skin's going to stay uniformly textured. Sometimes you get goosebumps, right? And those goosebumps raise up your skin. Think of these guys as being able to control when they have goosebumps, and also the goosebumps can produce spikes.